Basically, if you Google NZQA or NCA, you can end up on this home page, and I'm just going to click on subjects. From subjects, I'm going to go to mathematics and statistics. From there, I am going to go to level 1. It's an internally assessed standard, so I'm going to level 1 here. Alrighty. Now the one that I'm looking for is the trig one. So you need to know what number it is. Can anyone tell me what number this trig one is? So it's 1.7, and there's 1, 2, 3 different tasks. So the what's my angle one on page 120 is 1.7b, so we can go to that one there. Okay. And it takes a wee while to load. There we go. Okay. So that's how to find the actual task. Alrighty, which I'm going to go through with you, but you'll see down the bottom that's actually got the marking scheme as well. So that's our task. However, now that we've got this number, Control C, I'm actually going to look for exemplars. It's actually quite hard to see there where they are. So I'm just going to see if it's quicker to do it this way. Knowing something exists actually helps you find it. So I'm going to go like that, exemplar. Okay, now here we have a very important document. So what you get when you're here for that resource is exemplars. They're actually exemplars of student work and what grade they receive. So here, for example, a low excellence, you need extended abstract thinking has been demonstrated in both the SAIL and VAN calculations. A strategy has been devised to establish the dimensions of both the SAIL and the VAN. Correct mathematical statements have been used. Note, the student work included as exemplars for all levels of achievement has been for an earlier version of the task which did not entail the addition of the extra 2.5 metres to the pole length before calculating the dimensions of the van. And another note, the classification of low excellence is because some of the mathematical statements for the SAIL calculations lack complete clarity. So this person got excellence. So this is your way of seeing what excellence looks like from a student's perspective. So you can see that they actually haven't got a whole heap of working there, but it is clear. Now if we go down the bottom to achieved, so we look at a high not achieved. Should we look at a high not achieved? Yeah, let's look at that. Apply right angle triangles and solving measurement problems requires using a range of methods for achieved in an explanatory note 4 of the standard indicates that a range of methods is at least 3 different methods. The student only used, so basically this person here just did that, but they didn't have the 3 different things. Okay, so we'll get rid of that one and that one. Let's have a look at a low achieved. They've done trigonometry, they've used them to find a side, they've done trigonometry to find an angle, and they've used Pythagoras. So that's actually all the working that they've showed and they've managed to pass. Although it's actually A, B and C which must relate to the question. Okay. Now if we go up the top, you can actually get all of the exemplars for that standard in one big document, which is quite handy. You need to bring your own paper for this. So here's the actual thing. Now that one there, high merit. This next one. So this gives you an idea of, oh, that's a nice diagram, isn't it? Look how nicely they've said length of sail edge, AC, AB. So they've labelled it AB, 3.8 metres. That looks, AB does not look like 3.28 metres, it looks like 20 metres. That's interesting. Maybe that's why they didn't get excellence. But beautiful labelling. Okay. This one here. No, see the diagrams? See the 3D diagram here? See that they've actually written x over this equals tan, or we would write tan 13 times 3.4, wouldn't we? We'd go straight to there, but we'd write our formula up the top and our TOA triangle. Okay, so that gives you an idea of what your assessment might look like, that you don't have to write a story, but we do need to know what you're calculating. So going back to here, I'm going to copy that, go back to our maths, so that's that trig internal there, and I'm just going to put that link in for you, okay? So now if you can't find that link yourselves, you can get it there. Right, let's look at this together. So this is page 120 of your book. All right, we don't have the teacher guidelines in your book. Further down. Actually, we looked at this last term. Let's read it again together. Introduction. Your class has been given the task of calculating the dimensions of a fabric solar sail fixed in tension, so that means tight, at its corners so that the fabric is kept stiff. The manufacturer has asked you to supply sketches, i.e. draw diagrams, showing dimensions so that they can manufacture and deliver the solar sail to your site for evaluation. The activity requires you to take measurements to determine the dimensions of your unique solar sail, and then find the dimensions of a van required to deliver it to the site. Working in groups of 3, which you will be doing, you take measurements, and working independently, you'll get 1 period to analyse the data, perform their calculations and complete a sketch. You will be assessed on the quality of your discussion and reasoning and how well you link it to the context. Task: the solar sail dimensions. Your teacher will indicate, so this is what you'll be looking at when you come to do your measuring. You'll be given perhaps a diagram, perhaps not, and you have to measure certain things. So you're going outside and we say this is point A, this is point B, whatever. I don't know what's going to happen. So the teacher indicates the position of your particular sail by giving you a set of 3 points, A, C and D. The points A, C, E represent the corners of the solar sail. So in your head you need to be thinking of, grab it again, there, function print screen and control V. Okay, what you need to be seeing, although it's not, you need to see that the sail is like that. Does that make sense? Has everyone sort of seen that? Oh, that the sail... So you might take a bit of time understanding the task. So that's your sail, and it's tight, held tightly. So you've got the sail, and what you're given, A, you're given C, your teacher will give you A, C and D. So if you've got those, how on earth would you find those dimensions? What would you physically measure? So you might be standing here, you might be measuring that angle there, you might, oh hang on, you probably won't be standing, you might probably be standing there. So if you were standing there, you would be able to measure that length along here, which is the same as that length there, correct? So you'd be able to work out the height of the post. All right, and you would also measure this length between these two. How on earth would you find this length here? You'd find, if you've got that length and that length, what would you use to find this length here? Pythagoras, thank you, because that's a right angle triangle. You use Pythagoras. And then that's a right angle triangle. So you would use Pythagoras again to find this length here. Does that make sense? Yeah. You would have that. How would you find out that length here? Or should I make it red? No, black. That length here, how would you find that out? You've got the length there and the height, which you've calculated by doing that. Yeah? So to calculate that length there. Alrighty. So going back to reading our question, we need to find the height of A. This will be determining the length of the pole. Find all the dimensions to determine the size and shape of the solar sail. Write a description of the shape of the solar sail using dimensions you have found. So that's going to be a long way towards achieve, but we've got delivery instructions. The manufacturer will deliver the solar sail to your location with a pole that has to be placed at an angle of 13 degrees with the floor of the delivery van. The pole will be 2.5 metres longer than the height of the anchor point that you have calculated, so that it can be sunk into concrete foundation and still leave room for fittings to be fixed above the sail. One end of the pole will be at the left hand corner of the van and the other end will be at the right hand upper corner. So what you're seeing there is, it's quite good if you can actually draw 3D a little bit. Practice doing that. That's not particularly well done there. That the pole is actually going from one corner to the other corner. So if you had that dimension and that dimension, you can get that, then you've got that, that and that. You're doing Pythagoras twice. Okay, maximum allowable length of the van is 2.4 metres. Describe to the manufacturer how they could calculate the height and length of the smallest van they can use to deliver your solar sail with its pole. So go do now.